Hi everybody, in this video we are still in lesson 3 on falling objects, and we're going to pick up at the bottom of the page where we left off the last time. So question number 4, Batgirl jumps into the air and lands 4.2 seconds later. How fast is she going when she hits the ground? Okay, so if we think about it, she is 4.2 seconds is when she lands, which means that she's 2.1 seconds halfway through. So I can use this equation to solve for my final velocity. So final velocity is what I'm solving for. The initial velocity, as before, I'm just going to take half of this parabola. I'm going to start with my initial velocity. I'm going to say the initial velocity is 0 because she's just halfway up there, but that gives me an easy place to start to say what happens when she lands. The acceleration due to gravity is negative 9.8 meters per second squared. And we are multiplying that times the time, which in this case is only 2.1 seconds. Now, I will also say there are other ways to do this problem, but this is one of the ways, and this is a valid way to do it. Okay, so now we just need to multiply negative 9.8 times 2.1 and see what that comes up with. The seconds and the second squares are going to cancel out to give me meters per second. And so when I do that, I get the final velocity is negative 20.6 meters per second. It is negative because there's a negative here. It's also negative because it's on her way down, so that's why it's negative there. All right, the next question, what is her maximum height? Well, again, if we have the initial velocity being 0, which we're counting on half of our parabola, so it is, then I can use this equation that's just a simplified version of that longer equation. So I'm solving for her maximum height. Once again, her acceleration is negative 9.8 meters per second squared, and her time, in this case, is just 2.1 seconds. And I do need to square that. So now if I go get out my calculator and I plug these numbers in and see what I get, once again, the second squares and the second squares cancel, and I get 21.6 meters. And once again, the delta is, the change is negative, but her max height, I might write this over here, her max height is the positive version of that because that's where she started in this problem, where she started 21.6 meters. The change was she lost 21.6 meters because she came down, but the height itself is just 21.6 meters. Okay, let's turn the page. Okay, the first two questions up here deal with the same question that we were talking about a minute ago. It's just two separate parts. So I went ahead and wrote down that our final velocity that we came up with on the previous page was a negative 20.6 meters per second. So if Batgirl starts off and lifts off, if she's ending at negative 20.6, then she's starting at positive 20.6. So that is her initial velocity, is positive 20.6 meters per second, and her final velocity is negative 20.6 meters per second. This question is asking when or at what point, at what distance, is she moving with 25% of her original speed? So let's just take a second to take 1/4 of the original speed and see what that comes out to be. And so if I put that into my calculator, I get 5.15 meters per second. And so the question is when, at what point, at what distance, and this is our distance and this is our time, at what distance is that happening? So our final velocity, we could go either way on whether we want to go up or down. Let's just start with the initial velocity being positive 20.6 and then the final velocity being 5.15. Okay, so our final velocity, is 5.15 meters per second, and we need to square that. And our initial velocity is the positive 20.6 meters per second, and we will square that, and that's a 6. Plus 2 times a, which is negative 9.8 meters per second squared, and then delta x. And the delta x is what we are solving for. At what distance? That's what we're going to solve for. So I need to square these numbers, subtract them, and then divide by negative 2 times negative 9.8. Take a minute with your calculator and do this and see what you come up with. So when we do this in the calculator, we come up with 20.29 meters. That is the delta x. That's the distance above the ground that she is moving with 25% of her original speed. Keeping in mind that her max height, wasn't the max height like 26? I'm going to go back a second. Max height was 21.6. So here we are, the max height is 21.6, and then we're talking about 5.15 came at 20.29. So it's 25% of the max speed. Because of the curve, it's happening way up here towards the top of the curve. Okay, last piece of this problem, sketch of distance time, velocity time, and acceleration time graph for the motion. So we typically just kind of do graphs like these that are kind of vague, but we do know the time. So for instance, we could put a 4.2 seconds on this, and then halfway, of course, be 2.1. And we do know that the max height, like I said a second ago, was 21.6. And so I've already drawn this basically up above there, but here's our distance time graph. Our velocity time, once again, it would go to 4.2 seconds. We said that the final velocity was negative 20.6, and so then we knew that the initial velocity was a positive 20.6 meters per second. And so it starts out at 20.6 meters per second. Halfway through, because of this diagram, halfway through she's at velocity 0. So she starts off, she slows down, and then by the end she's at negative 20.6 meters per second, and so she's going to end up here. So this line is the representation of her velocity. Starts out fast, slows down, and then once she gets to the top, she speeds up again, and she's back to a 20.6 in the negative direction when she lands. The acceleration the whole time is negative 9.8 meters per second squared. That is her acceleration the entire time. So that is listed there. Okay, new problem. During the annual pool party, Robin jumps off a diving board with an upward velocity of 3 meters per second. The board is located 1 meter above the surface of the water. So over here I have a little diagram. Here's Robin. He's going to dive off, initial velocity upwards of 3 meters per second, and he is 1 meter above the pool. Okay, so relative to the surface of the water, what is his maximum height? So he's going to jump up here, he's going to land, and so forth. Well, once again, we can use the 3 meters per second as the initial velocity, and then when he gets to the top of his arc, or when gravity brings them to a stop, basically, the final velocity is 0. So I can put in the final velocity being 0 meters per second and square that, and the initial velocity being 3 meters per second and square that. Of course, 9.8 meters per second squared is my acceleration, and delta y, that's what I'm looking for. So I'm going to go ahead and use that equation. So I'm going to take some time with my calculator and see what I get. When I divide this out, I get a 0.459 meters. That's how much the change is. But remember, that is the top of the arc, and the pool, the board is 1 meter above the pool. So I actually need to add 1 meter to that. So in other words, the max height is 1.459. That's my max height. Okay, well then how fast is he going when he reaches the water? So at this point, now if we think about like that second half of that parabola, so he started here, we went up, we calculated to here. Now let's look at the second half of the parabola. And for the second half of that, final velocity is what we're solving for. Initial velocity is going to be 0. So let's go ahead and start putting in some of this information. Initial velocity is 0. We know that acceleration is negative 9.8 meters per second squared. And the delta y is what we just figured out, but this time we want the 1.459 because that's the whole distance that he travels is 1.459 meters. And so once again, I'm going to take this and put it into my calculator and see what I get. And so when I multiply that out, I get 28.616 meters squared per second squared, but that's for final velocity squared. So I actually need to take the square root of both of those numbers so I can get my final velocity. So go ahead and take the square root of that on your calculator. and I'm getting 5.35 meters per second, and that is downward. It didn't come out negative because we took the square root of it, and so that can't be a negative number, but that is a downward velocity. Okay, at what time is he moving at half of his original speed? Well, the original speed was 3 meters per second. And he ends up hitting the water faster because he didn't start at the zero, right? So the final velocity that we're talking about is going to be half of his original speed. He started at 3, so his final velocity here is going to be 1.5, I should say meters per second. The initial velocity was 3, and acceleration, of course, is negative 9.8 meters per second squared, and time is what we are solving for. So again, I'm going to take a second to solve this for time and see what I get. And I'm getting 0.15 seconds. At 0.15 seconds, he will be moving at half of his original speed. So that last question was asking about time, and this question now is asking about height. So at what height is he moving with half his original velocity? So now I need something that has a height in it. So I'm going to use this equation now. Once again, my final velocity that I'm talking about is half of the original, and it's in the opposite direction, so that's why I'm choosing my negative now. So my final velocity, I'm looking at a negative 1.5. Initial being 0, again at the top of the parabola there. And of course, we know what gravity is. So I can just plug this information in and do my math and figure out an answer here. So take a second with your calculator and see what you come up with. Okay, so I'm getting my delta y to be negative 0.114 meters. And so again, if we think about where that is, the 0 that we were talking about was up here at the max. The final velocity is the 1.5 on the way down, and we are saying that the change in y is negative 0.114. Remember, the max height up here was 1.459, so we now need to subtract those two numbers to come up with our, because it's asking what is the height above the surface of the water. So 1.459 minus 0.114 is going to give us our answer. So if I subtract those two numbers, I'm getting 1.345 meters above the water because it's 1.14 below the max height. Max height was this, so this is how much above the water it is, which is what the question asked. Okay, last thing, sketch a distance time, velocity time, acceleration time graph for this motion. So this time, he starts 1 meter above the water, and the max height is 1.46. We had that up there, right? Yep, 1.46. And so he's going to jump up, get to that point, and then come back down and come all the way down here to the end. And we did calculate how long that takes. I was wrong. I thought we had calculated how long that takes, but we actually didn't. So we don't have any information here. We do have this 0.15 seconds, but we don't know how long it took for the whole thing, at least as I'm looking at it. I can't find it. The velocity starts off fast, slows down, and then increases speed. So starts off with 3 meters per second, slows down, and then increases speed. And this portion over here is a longer time because the parabola is like this, and we started over here, and so that center point is going to be off a little bit, and I don't have a great drawing with that, but I hope you understand that there is a longer section time-wise over here than there is in the first half. And when we get down here, we get all the way down to negative 5.35, which we had also calculated up there, 5.35. The acceleration the whole time is negative 9.8 meters per second squared. All right, we will continue to work on some of these falling object problems in class next time.